In this lab, tensile testing of aluminum 6061, titanium grade 2, and AISI 4140 steel was conducted by Ashton Ventura,
Keegan Flackey,
and Clark Wynn
to determine key properties such as modulus elasticity, yield stress, ultimate tensile strength, percent elongation, and reduction of area. This testing used an MTS 37.50 load frame, along with the MTS LX laser extensometer.
To begin the lab, 3 unknown samples were identified and classified on material based on weight, as steel is the heaviest and aluminum is the lightest. 1 inch from each side of the center was measured on each sample using calipers and marked with a Dremel. The tensile testing machine was also set up and the equipment was calibrated. For each material, standard specimens were prepared after recording their initial dimensions.
The differences between the titanium, steel, and aluminum in terms of necking and fracture can be seen during the test. The red laser is from the MTS LX laser extensometer, as it shoots a laser at the sample and reads the distance between 2 strips of reflective tape that are placed 2 inches apart.
During the test, load versus extension data was recorded, which is crucial for calculating stress and strain. Each specimen was pulled until failure, so each property from elastic modulus to fracture strength can be measured. Next, the engineering stress and strain was calculated and plotted for all 3 materials using MATLAB, and they were analyzed and compared.
This is the titanium graph. The stress-strain curve begins with a linear relationship representing the material's elastic deformation, reaching a yield point of approximately 400 MPa. This region of the curve is relatively flat, indicating that the titanium grade 2 can undergo significant plastic deformation without significant increase in stress. The titanium grade 2 has good ductility with an elongation at fracture of around 20 to 30%, meaning it could stretch considerably before breaking, which is reflected with the high strain which can be seen.
In steel, we see it is a lot stiffer, so the yield point is a lot higher, being around 650 MPa. Due to its alloy composition, AISI 4140 exhibits a higher work hardening rate, meaning stress increases more significantly with further strain compared to aluminum or titanium.
For aluminum, it has a low yield point, reaching around 300 MPa. After yielding, the stress remains relatively constant as plastic deformation increases. Aluminum 6061 has a more gradual transition from elastic to plastic deformation compared to the steels. The strain associated here is much lower than that of the titanium grade 2, but was greater than the steel. As seen by these test results, steel was the strongest but most brittle, and titanium showed both high strength and good ductility. Aluminum had a lower strain than titanium, which suggests that it not only had the lower strength than titanium, but also lower ductility. The ductility is still higher than the steel sample. The properties displayed by these tests are important because they show when a material responds to certain loads.